Okay, so ready for day 9 of Advent of Code. So yesterday I did it by myself, didn't stream anything, but today we are back at it. So let's start from the day 9 challenge. Disk fragmenter. Okay, this already seems difficult. Another push of the button leaves you in the familiar hallways of some friendly amphipods. What are these amphipods? We don't know. It's something from 2021, actually. We are getting closer to 2024. And good thing you somehow got your own personal mini submarine. The historians jet away in search of the chief, mostly by driving into walls. While they figure out how to pilot these things, you notice an amphipod in the corner struggling with his computer. He's trying to make more contiguous free space by compacting all of the files, but the program isn't working. You offer to help. As always, the IT guy offers to help with fixing computers. We are shown the disk map he has generated, for example, this. So the disk uses a dense format to represent the layout of files and free space. Okay. So the digits, each digit, alternate between indicating the length of a file and of a free space. So 1, 2, 3, 4, 5 would represent a 1 block file, okay. Then a 2 block of free space. We have a 3 block file, a 4 blocks free space, and the 5 blocks file. 90909 would represent 3 9-block files in a row. Each file on the disk has an ID number based on the order of the files as they appear before they are rearranged, starting with ID 0. Okay, so the disk map here has 3 files, a 1 block, okay, 1 block file with ID 0, 3 block file with ID 1, and a 5 block file with ID of 2, using 1 characters for each block where digits are the file ID. Digits are the file ID. And dot is a free space, the disk map becomes like this. Okay, so we have the examples. The amphipods would like to move file blocks at one at a time from the end of the disk to the leftmost free space block. For example, this disk map leads to this result, and the other examples require a few more steps. The final step is to update the file system checksum. To calculate the checksum, you add up the result of multiplying each of the block's position with the file ID. Okay. So we start from position 0. Each block is a position and needs to be multiplied with the file ID. Okay, so we have the example, which is 1928. Compact the hard drive using the process requested. What is the resulting file system checksum? Okay, hope we can do it. Let's start. So cargo scaffold day 9. Let's copy the example here. He shows it. Okay, for example, this is the first one. Example 9. It's a single line. At least we don't. Oh, this is the real example. It's a single line of. Let's create a single line of 20,000 characters. So if we go correctly, 20,000 by 10, which is the number of digits, gives us 200 kilobyte of memory fragment to defragment. Okay, let's start with some simpler tests, and I want first to try. This is just a try. I try to defragment to generate the hard drive given the dense representation, and then we can defragment it. Okay, so we can start with a string and we can test the generation. So let's write a first test, which is test representation test expansion. So we want to assert that the expansion of the first example we have, which is just 1, 2, 3, 4, 5, So we have the input, which is 1, 2, 3, 4, 5, and we want it expanded as this thing. Let's start with this. This is expand the input. Okay, so for each block, we indicate the ID of the file. Cargo test. min09. Min09. Now, it doesn't compile, but we can start with something simpler, which is, and let's use RSTest for this. As always, we have the case, which is the expected result. The expected result, which is a string, and the wait for my hands to wake up. The input, which is again another string. So let's start with this, which is a test case of these two. This is the case, this is closed. It doesn't work like that because we are getting attributes. Okay, this is the, oh, now we expand the input and we want to get the expected result. Let's import RSTest. This expand does not exist. And let's start with the simpler example, which is empty string. Returns an empty string. This is TDD, basically. So, if we write the function expand, which takes an input, which is a string, and returns another string, we start with this. Doesn't like it, so this doesn't pass. We can return an empty string. Actually, we can return a reference, but it's not what we need. We need a string. And we can return in. So this passes. Let's go on with another example. We want a single file block, so it will return 1. Again, this doesn't pass. This is the least we can do. So if input lamp more than 0, we return 1. This is the least we can do to make the rest pass. So let's see if we can do that. It passes. Let's go on. We need a 2. So we need 2 spaces here. This is getting more complicated. Now, can we multiply strings? I don't think so. In Rust, at least. It would be really nice if we could do that, but we cannot. There's a repeat, so we can try to repeat these n times, and n is equal to input 0 dot parse as util2 for the size. It doesn't like this. Input bytes, let's say, and this is no. Input as bytes, but this returns a U8 as I want chars, but it's okay. We can also do chars collect and chars of 0. This is a vector of char. There's no char here, so we can just do something like let's do it with U8. So chars is a vector of U8 as bytes, and this chars of 0 is minus 0. This should return a no. This returns a U8. Okay. Should be okay. Fades because we are not repeating the. No, wait, it's the opposite here. We need this to be okay. Now, if we go on, we will find that if we go with 3, we will find that these work, right? So let's go with our space. We have 1 and a dot for a space. So we have 1, 1. We need to have 1 dot expanded. So we can write an if again. If input len is 1, else if input len is equal to 2. But this is not right. I mean, we should return 1 repeat plus 2 repeated, right? Repeat plus 2. No, we don't need 2, we just need this. Repeat again. Chars of 1 this time. We will refactor this later, I think. This is 1. Now, addition doesn't work like that, I think, with strings. It should work, but it's quite ugly. And if you see, if input len is 2, then we are summing this. So we could go on to 3, so like doing this. So it's 1 dot 2, and this is 1, 1, 1. And we can make it pass. Else if 3, we're doing this. And another thing, we're doing 2, repeat chars of 2, and again, this should work. But it's time for a small refactor. So if we have chars, we have an index, we can do a for loop. So for edx, no, wait, we don't even need that. We don't even need to repeat this. I mean, we could. So let's do it. So let note output, which is a string. This is a string, and then for edx in 0 dash dash chars len, or for characters in char len, in chars, we can take an index, let note edx, or ed, which is right now 1. We can write 1 of c minus 0 as your size, and this one is instead ed, the string, and repeat. And we do out plus equal to this, right? And then we can return this plus equal is not right, so out is equals to out plus. We cannot add a string to a string, but we can add this. Still not right. Let's do it another way. So we can do let out. Let move out is not a string, but it's a vector of bytes. Vector of weight. It's an empty vector of weight. We have an ID, which is a number, which is actually the number. It's a char. So we can do out insert. No, I want to append another vector, but I can also let's do so number of chars is equal to c minus 0 as u8. And with so we want as u size. Then we can add for I in 0 n. We want to do out push C. No, not C, but ID, which was our char. And we want to do another thing, which is ID plus equal to 1. It doesn't work, but we can do ID plus 1. This plus doesn't work. We can do the as UA and then as char. Now the ID could actually be more than, I mean, this number. Yeah, we are not getting closer to that. So this is totally wrong. I just thought about this. This number will for sure go over 9 after a while. I mean, if you look here, example, it doesn't, because the example is done in a way to not show you that it goes over 9, but it will go. So let's do this again and convert the ID is a number, so we have a vector of numbers which goes out instead of a string. Okay, so the expected is a vector of u size. U32 should be fine, and we can use 0 as a placeholder for the dot. So here we do. This is a vec. This is a vec containing 1. This is a vector containing 1 and 1. This is vector 1, 1, 1. This is vector of 1, 0. Here we have a vector of 1, 0, and 2. Okay. Let's do it again and let's hope it passes. So here we can use ID as 1. We push. Out is a vector of u32. Let's return out. This is okay. The ID is a u32. And we can do out push id and then ID plus 1 plus equal 1. This doesn't work. So the refactor is not done because we are not handling this is the size of the chunk. So let's rename this. Chunk size. Thing is let. We need to be to check if it's file. So is a file is equal to true, and this file is equal to false. This n is chunk size, and this I is not needed. So let's test this again. It's still failing because we didn't change the flag. Still failing. Okay, let's see why. Oh yeah, we need to write either if is file, we write the ID, else we write 0. That's why. Okay. Thing is, the ID needs to go up only if it's a file. If is file, the ID goes up. Okay, now it's working again. Let's test it with some other examples. So, for example, our test case. Now we need to transform this into a vector. So we have zero. Oh, so we also have zeros here. Wait, let me check. Oh, okay, so it starts from 0 always. This was quite wrong. I need to change my test. So how can we model this again? We can yeah, this is not working all right. So this is the 0 exists, so we need to use an option. Maybe we can just give options of U32. Here we push some of ID, and else we none for a free space. Okay. Here our test becomes more complicated. So everything here is a sum of 1. Sum of 1. It's not 1, it's 0. Here is 0. This is a none. This is a none. Sum of 2. This is quite longer, so it's sum of 0. Then we have 3 nuns. Now we have 2 nuns. We should follow the example. We have 2 nuns, then we have a 3, sum of 1. So let's copy this 3 times. 1, 2, and 3. Then we have 4 times none. None for 1, 2, 3, 4, and then 5 times 2. 5 times 2, it's this one. I forgot commas. Let's test this. It's not working, but why? Because we didn't collect the vector. Okay. Option of U32. And again, we test. Let's see what is happening here. And ID is U32. And out must be a vector of option of U32. So now it should work. It doesn't pass. Okay, we are starting from 1. We should start from 0. Still getting errors because we wrote them in the wrong way, because this starts from 0 and not from 1. This is a 0. This is a 1. Okay. Okay, Sbus, we have an expand method. So first thing we've done, we have expanded the file. Then we need to test our defragmentation procedure. So we can start from the examples again. And we start by writing, we can also, how do we do it? We can just write the fragmentation procedure like this. So test the fragmentation. Let's write a first test. We have expected, which is our vector. We have a vector in input. So we have an input. And we want to assert that the expected is equal to the frag of input. The frag will take So let's try to write an example for this, a simple example. We could write the first one, but it's not so easy. So maybe let's start by creating the method. So the fragmentation is given a vector of u32. We return a new vector of u32. Or should we do? I don't want to do it in a line, so let's just copy the memory. And how does this work? We create a new. Let's start by returning an empty vector. This should pass the test. Doesn't. We should take a reference to input. And the expected is a vector of u32. Again, we pass. Now we can write some more difficult tests. Again, we just want to test simple behavior. So the first is, if it's empty, then it comes back empty. It's the one we already brought here. So that case expected, which is a vector of option of u32. Input is another vector of u32. So in this case, this is vec and vec. We didn't put the case here. Case. And the frag should take an option. I forgot about my idea. So let's take an option of u32 again and return an option of u32. Okay, passing as expected. Now, it should return the same vector if something is full, and it's not doing that. So we can just return input back. Okay. Another test. Now we need to fill some empty space. So if we have something like sum of 0 and none and sum of 1. No, this is the result should be this. The input should be the opposite. So we have free space in here. This is already difficult. So let's create a copy. Let mu output input. We return output and we go output of 1 equals to output of 2, and output of 2 equals to none. This is our swap operation. And it's failing. So how can we do that? We can put an if. So if output of 1 or none, then we try to do this. Still not working because we're out of bounds. So output len more than 2, and the output is none. It's passing. Now this is quite ugly. We will make it more general. How can we test a similar thing? But I want to test that we can put the 1 in here from anywhere. So let's try with more none, and I want this to happen. This is not happening, so I get output of 1 from the last element of the array, or at least the last element which is not none. This will be quite a long series of tests. So we get from output len -1, and we put this -1 to none. Why is it not working? Oh, because it's borrowing. So we should put something like a end, which is output len -1. And we put end here and end here. Okay, it's not working. Let's try inside the if so we can be sure. It works. Now, I want to refactor this. So if output is empty, we return output. It's okay. Otherwise, we already know we have something here. We have the end, which is output len -1. And if output of 1, if output len is more than 2, is more or at least 2, we can swap. Still passing. Now, how can we expand this? We need to pass from an if to a for loop. So I want to write another test. If we have something like this, I want to have still the same result, but putting the 1 here. Now, we should, if output of 1 is none, we don't get it from the end, right? We get it from the latest place. So we can do this while the output of end is none, we go on and we do end minus equal to 1, then we swap, right? Okay. How can we remove this? Maybe we can. Let's try to refactor. No. We can try. We can try with a longer array. So, for example, with this, which is in which maybe we have a 0 here again, and we want 1. This because we have some 0. Then we have none. Then we have sum of 1, and then we have none. Here there are 5 elements. Here we have 5 elements. So again, let's test this out. Doesn't pass because we want to switch. This is 1 is not output of 1. Is the first empty space. So we can do this. Start is 0, while output of start is not none, which is also some. Well, it's some, then we go to the right, so we start and we go over. Then we can swap them. So we go back with this, and output of start equals to output of n, output of n equal to none. It doesn't work for case 2. Case 2 was this one. You don't need to swap them. And this goes over. So if we are finished, if start is more than output len, or if end is less than 0, if it's not this, I mean, if start is less than len and end is more than 0, more than or equal, then we can do the swap. So here we do this. Still case 2 is not. All right, so let's wait. Let's format the document. Doesn't work for case 2, in which we don't have to swap for none. So we just need to swap if output of start is none. Again, this is the same if we had before, no, not this. Can we do this? How can we do this? Now, why is it working for the others and not for case 2? Case 2 is, I think, this one. So let's debug our start. Now end. In case 2, we have out of bounds. The len is 1, the index is 1. Thing is, it went let's find looking at line 44, which is this one. So while start is less than output len, and is now it works. I just needed to put an if. Okay. Now let's try something else. Let's try with more elements. So we have, no, this is not our, this was the expansion thing. Let's see what happens with something more fun. We have this, we have sum of 1 and sum of 2 and 3. This is the input actually. Wait, this is the input. So if we have this input, what we want in output is to move sum of 3 here and to move sum of 2 on the left, leaving 2 nonce at the end. Let's test this. Okay. Now we need to move multiple numbers. What we are getting is instead sum. We moved the sum 3, but we didn't move the sum 2. So how can we do this? We can do this by writing a while. So while start is less than output len, we go in circles. We go like this. I hope. Because while start is output len and is more than 1, because if we go at 1, then we are finished, because 1 is as always something inside. We do this. We go with start, we go back with end, and if start is still inside the array, we swap. Okay, let's see if this test passes. It doesn't pass us now. Doesn't pass, so that's because in the end was not right. No. We're doing too much, I think. So let's go back to our passing cases. We just have the case 7, which is not passing. So 1, 2, 3, 4, 5, 6, 7. This one. We just need to apply this until the start is gone. This is right. This actually is right. So we just need to move the start. So here we swap. We move start to the left. We move end to the right. Not to the left. Here. To the right. To the left. So, okay. We can refactor for later. So what's happening here? What is happening is that we have start and end, which in some cases, for example, let's see one test failing, this one. Start is equal to 2, end is equal to 3. Start is equal to, so this is case 6, which is this one. Start is 2, so it's this one. End is 3, it's this one. We move end here. Then we have start equal to 3. End equal, oh, okay, I see. Start and end must not interact, so the end shouldn't go here. So while start is less than output len and end is more than start, because otherwise we're done, we're still getting some errors. So for example, case 6 now is this, because start is 2, and no, while end is, yeah, if it's more than, then we need to stop, right? But we should do that in here. We should do it here, maybe. Now it passes, and we can refactor this shit. right? So we have some test passes. This should be the algorithm, actually. It's working quite all right, but we need to clean this code, otherwise it won't work at all. I don't think we need this here. No, we still need it. Okay. Special case. So how can we clean this loop? We can remove this, because for sure it will work. Okay. This is all right. So we can maybe swap this one. This is all right, and this is the one I don't like, because we should do this. First we can do this. We can do this, okay. It works. And I mean, we can keep this. I don't think we need this, actually. Yes. Because if start is going to the far right, then it's for sure over end. I mean, we can keep this code. Now we can write the test. We can write the code to compute the checksum. So we can write a test for the checksum. Fn test checksum. So examples again. We can try with these inputs. These are the defragmented outputs, so let's just write some tests with this. These are the outputs. We can write something like what we expect from here. So we expect for sure the 0 here. We expect a number, and we expect here a 0. Here we expect a 1. Let's write a 2, which should be 1 plus 4. This should be 5. So let's see. In the first example, we had these two. Yeah. We have a 5. Here we have, let's try with this. We have 3 plus 2 plus, no, 0, 1, 2, 3. So this is a 6. This is a 2, and this is a 3. 6 plus 2, 8 plus 3 is 11. Okay. Now test checksum of the first case is the expected, which is U32, and the input is a vec of option of U32, which is our output from the defragmentation. We assert that expected is equal to checksum of. Now let's start with the first example. I don't want to go too fast. So first let's create the checksum method. This is our function checksum. Takes a vector reference to vector of option of U32. It returns a U32. Let's make this pass and return 0. It's not working because we didn't pass the reference. Now it's working. Again, this is coming with 0. This is not changing. Let's go with 1. So if input len is more than 0, we return 1, else we return 0. Still failing. Why? Because on the left we are checking the wrong result. We want a 1 here. If it's more than 2, then if it's more than 1, then we return Now, this is a difficult case. We need to return 5. So maybe we can write a simpler test, which is this. We write 2 test cases. In one, we return 2. Right? Doesn't work. Now, here we should return 1 by the index. So if len is more than 1, that's all right. But if len is more than 2, I mean, we should just write the for loop, right? Let's make it pass. If we have an input, we can... We don't need to sum yet. So if len is equal to 1, then we return 1. Else, if len is more than 1, we return 1 by 2. Again, no, this doesn't pass. If it's equal to 1, we return 0. If it's equal to 2, we return 1. If it's equal to 3, we return a 2. Okay, we're not passing some tests. Here we need a 2. This was the right thing to say. Let's try again. This is not passing. We should return a 1 and a 2. So we should return 1 and 2. No, let's keep it like this. I mean, we should just return this. Let's do it better. I mean, I don't want to stay here for hours. So for I in 0 input len, sum plus equal to I by input of I. Right? But only if let some value equal to input of I. Right? We have this then sum by value. Sum by value. And we return sum. Right? Now I by value. We expected a U32. This should work. Okay. Let's just uncomment this one and see that it works. Okay, now we test part 1. So for part 1, we have an input example. We want 1928 as a result. Doesn't work, but we can do it easily. So for part 1, we get input and we let expand it. We expanded input, then defragged expanded version, and then we return the checksum of the defragmented. Right? Let's see if our methods work together. It works, so let's go on and solve part 1. It panicked. Okay, he attempted to add that with overflow, so it's way more than U32. Let's try with U64. Now we will have to change everything here with a U64. And let's see if this works. Okay. It's quite a big number. I hope it's the right one. It seems very big. I mean, it's an exponential, and that's the right answer. So let's go to part 2. On completion, two things become clear. First, the disk has a lot more contiguous free space, and the computer is running much more slowly. Maybe introducing all of that fragmentation was a bad idea. The Ampifod already has a new plan. Rather than moving individual blocks, I'd like to try compacting the files by moving all files. This time, we attempt to move whole files to the leftmost span of free space blocks that could fit in the file. Attempt to move each file once. Okay, we attempt to move each file once in order of decreasing file ID number, starting with the file with the highest file ID number, okay? If there is no span of free space to the left of a file, if there is no span of free space to the left of a file that is large enough, the file does not move. For example, here we can move the 2 9s to the left, like this. This one. We can move the 4 8. Can we? We don't have space for them. But we can move the 3 7 here, because we have space. We can move the 6. Okay. Oh, no, it cannot move the 6, cannot move the 5. Okay, cannot move the process of the data system is the same. Now this checksum will be 1. Okay. So now we need to compact with another algorithm, which is quite different. We need to find not the first space available, but first big enough space available. Yeah, maybe the process is the same. We just need to update our data structure. So let's try to do that before. I think we can do it by having a pair of file ID and size. So for example, we have when we expand, we don't return an option. I mean, we return an option. This one. We return a. We can treat every every block. Now, what would happen? Right. Okay. What would happen if we add a size added to each? Yes, to each thing. Yeah. Also need to update every with U64, otherwise it will not work. Let's do this and test the project so we can still check that it works. Okay. Now the same algorithm doesn't work. We could do something better. So let's keep this part here. Let's keep the checksum is the same. What we need to do is work on our defrag. The fragmentation should could keep the ID and the size of it, but this will mean splitting stuff. So and it would mean moving stuff around. I don't like that, but we can try. So I go without TDD right now because I want to go a bit faster, but it will be much more difficult. Also because this algorithm worked without sizes. And with sizes, we need to check the first element, the first free space of the size, of that size. Okay. So let's try to brainstorm a bit. We need another thing, which is a file structure or file. File has an ID. It can have an ID, which was the option, and must have a size, which is a size 64. You decide. Then we have the disk, which is a vector of files, or I can call them blocks. A block can be either free space, or we can just do it like this. A block can be free. This is an enum. Can be free of a certain size, which is a U size, or it can be a file which has an ID, U64, and a size. Right? Need to give them names. And the free one just have a size. And the file can be like this. Their disk is a vector of blocks. So we can try to work with this kind of data structure and refactor all our code to use this. So we can have we should try to refactor everything here. It will be much more difficult, and we will need to change the algorithm, but we can do it with the same procedure. No, we cannot do it with the same procedure because we are looking for the... I mean, we can do it. Just do it in brute force. Also, the expansion doesn't work like before. The expansion will just create the blocks. So we now need to refactor everything. Okay, let's start by writing the algorithm, and then we can check. We can refactor the first part. So let's start from scratch. In here, if we have let's start with the defragmentation procedure. So we can test, and we write a test defrag blocks instead of single elements. We have, let's try to see, we have let's try with the example. So if we have this example, which was let's do it like this. Let's copy the example here and hope that it comes with the example. In this case, we have 0. Okay, so we have a vector. Our disk will be a block file with ID 0. So let's not use this, otherwise it will be too long. We have a U64, which is the ID, and U64, which is size. U size, sorry. We have the first, which is 02. Then the second, which is an empty space of 3 blocks. Then we have a file which has ed1 and this big 3. Then we have a free block of 3. We have a file which is too big 1. We have a free block of 3. This is quite big. 3 bytes. Then we have the 2. You know, we can just do this. And okay, we can just convert this into block file of, we have a vector, starts here, ends here. We can go over there, tell this to go here. Now we have a block of a file big at big 2. Then we have a free space of 3 dots. We have a file called 1 and big 3. We have a free block of 3. We have a file called 2 long 1. We have a free block of 3. Then we have a file called 3 long 3. We have a free block of 1. We have a file called 4 block 2. We have a free block of size 1. We have a file called 5 with 4 blocks. We have a free block of 1. We have a file called 6 long 4. A free block of memory. We have a file called 7 long 3. Another free of 1. A file called 8 long 4. And a file called 9 long 2. What we want from here is to create a new array, this time with this thingy. So let's try again. We have 0 with 2. Then we have 2 9s. We have the 2. This is already different from before. Okay, so we have the 9. Then we have the 2, which has been moved here. We have 1 by 3. We have 7 by 3. Then we have 1 free block. We have a 4 by 2. We have a 3. We have 3. We have 3 by 3. Did we have? Yes, 3 by 3. Then we have a 4 block free space. Then we have a 5 by 4. Then we have free space. Then we have 6. Then we have 5 here. Then we have 8. And then we have 2 of free space. Right? This is the expected. This is the input. And we want the assertion to be expected equal to the frag blocks of input. Okay. Let's rewrite the defragmentation procedure in a similar way to the one before. So with the frag and the frag blocks. we return a vector of block, we get a vector of block. We can also try to mutate in place. It's right. So we have a mutable reference, we modify it. Okay? So without copying memory, maybe. So track blocks of input goes right here. The input is mutable. And we get back input. We are not applying. Okay, we need to derive something for block, which are EQ and shake. Okay, let's test. Doesn't work. We need to create the new. We need to modify the input actually. So we don't need output. We don't need to return anything. We just need to modify the array. So let's do it. We start from the biggest. Now we can do what this would be more than n squared. I mean, should be n squared, because we will do something worse than this. So let's go. We do. Let's try to do it in a brute force way, in the same way the algorithm is written here. We go to the latest block. So we need to go to the latest one. So while input of n different from while input and is free. Now this is free is up to debate. We need to write that. While it's free, then we go on the left. Right? Then we need to find the start. So why? Start is less than end, and input of start is not free. So it's fine. Okay. We go on the left. Now, while it's a file and input start, no, and let block file of nothing size in input of start and size less than input and let block free of size equal to input and should work. No, it doesn't. Can we implement something on the enum? So something like impl block, and we say size. First is 3 of self, returns a boolean, and met self. We can do this. Yes. If it's 3, then is true. Otherwise it's false. Same thing we can do with this file. And other thing we can do is size. We always have a size. So we can always return size, right? We always return a new size. We always return size. So this should work. If it's 3, then it's 1. Then if the file, if the input start size is less than input end size, we go to the right. If start is less than end, and again we check this, because if this happens, if it's more than the size, then we can swap them. So swap them, and this goes on every time. Start from the left, and again, and again, and again. So no, yes. And this goes on while and more than 0, more than 1. Let's say. Now the swap is another thing. We should first. Okay, let's do this. If the let's check if it's all right. So how does the swap work? If the, let's give names to these ones. Input of start, which start should be a file. Input end should be a file. Input start should be free block. So if let's call this left and right, otherwise we won't get. So this is right, and this is left. Okay. If while right is more than 1, while right is a free block, we go to the left. Or we go to the next block. So we need to get to a starting to a block, a real block. Now we go from the left, while we are on the left, and the left one is less than the right one. Okay, and so we need to go to the left until we find. So if it's 3, if it's 3, or on left is less the input size. So if it's a free block, we don't need him. If it's not free, so if it's file, we don't need him. Otherwise, we want the size to be more than the one on the right. If that, so if we are still on the left is free, and the size is more, then we do this input. We take a temporary thing, so which is the same as input left. Input input right becomes a none block. So we can just swap it. We can just put input of left and input of left becomes input of right. Thing is, if temp size is more, then this is more or equal. Okay. But if it's more than the one on the now left, we should create an empty block. So we should insert. Let's see if we can do that. Can we insert something? Shifting all the elements. So at position left +1, we should do input insert at position left +1. So on the right of it, we should create a new block, a free block of size input right. No, wait. Let's do it again. So let's also do the which is I want to clone and copy this thingies. So let's do this. The block is the one here. The file block is the one on the right. Okay. Now, input of right becomes the free block. Okay. Input of left becomes the file block. So we move the file to the left. Then if the free block size is more than the file block size, we need to insert on the left a new element, which is free block size minus file block size. Okay. And we go again. And is the right okay? I mean, we should do something like right plus equal to 1. No. We can keep it like this. Could not compile. Okay. This is expected. We need to derive arc here. Block cannot be formatted. It's okay. 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 It's an infinite loop, so we're not going anywhere. How can we test this? We can test this by, I don't know. I mean, this algorithm should work also for the smaller blocks. So we can try. This is a big refactor that I'm doing. I hope it works, but a big refactor. So let's try to see. No, I don't want to change anything in here. So let's test again. The expand. Yeah, we need to change everything. And it's already 1 hour and a half almost. So Let's do it like this. Let's do one test. We just need to check the defragmentation procedure. Let's do it like let's do it. Why is it going on a... We didn't check this, so this one is not working. So we need to move the right to the left. Not here, but here, because yeah. So if we add a block in between, the right is already moved to the left because we moved all the array to the right. If the blocks were of the same size, we need to go to the left by 1 to continue the loop. So here, it's still not stopping. Okay. This is not a big array, so should work right away. We can try to print something, but I don't think it will work because maybe this while here. Yeah. Right, more than 0. Should panic otherwise. Let's print something. I don't think it will print anything because we don't know. Let's return here. So return. We need to return. Let's try to return at the end of the first. And it's still blocking. So I think it's blocking here in one of these two. Otherwise it will then return right away. Let's return back at the beginning. So here it's failing. Okay. We like this. Let's return here and see where it's blocking. Okay. Here is not blocking. It is blocking right here. No. Okay. So where is it blocking? It's block. Let's block at the first. Okay. So in our first loop, we moved nothing. Why? We should have moved file 9 into the first free space on the left, and we didn't. So let's debug things. Let's debug left and right first and see where it went. So left is 0, right is 17. Is not what we expected. Left didn't grow. I mean, it stayed 0. Okay. But why? Let's see our tests. So here we have a dd of 0, size 2, and 7, 1, 0. Okay, it's still here. They didn't move at all, so how can it be? This is a file of size 2. Should move. I mean, it should move. So here we should see that the right stays there. And left should go to the right because input of 0 is a file. And left is less than right. So why didn't it go to the left? Let's see. Let's go. It didn't even go into the while loop. So input of 0 is a file, right? Let's check these methods here. So let's write this loop right here in the left. Let's debug this. I think the is file is not working. Yeah, the is file is not working. Yeah, I made it wrong. So this is the right way to do it. And this should work. So let's see our first swap. I think it swapped correctly because it put the 9 here, added a free one here, and the same is the rest is the same thing. Right? Okay, so let's make it run. Hope it stops somewhere along the line. It doesn't. Okay. So again, let's go. We should debug this, but let me see. No, it's not stopping. Okay. Maybe this code was not right after all. Let's see. Still not stopping. Okay. Let's print in here what we have on the left, what we have on the right. Let's do it here. Why? All right. We just debug them. Now, what if I test just this one? Running, so Rust print if we do a no capture, maybe we can print. No, we can pass the no capture to the test. Okay, so they are the same and they shouldn't. So where am I debugging? Left and right are the same. Right didn't move at all. So we're stuck at the first. We're still stuck. So let's do this. Move it every time. Still, it's stuck. Okay. Oh, right. Right should go on the left. Every time. Even if it did nothing. Okay, now it's failing, but we can check why it's failing. So the right is okay. Okay, so let's see if it's the right one. Let's try to write this and check if it's the right one. So the file is 0292, then we have a 211373. Here it becomes different. Why do we have a free space here on the left of the 2? So in our example, we have this. Why do we have it here? Oh, left of the 4. So we have the 4, which is right to be here. we should have a 5 here, and there's no 5. So what is this 3 doing here? Oh, okay, it moved. Okay, then we have a... Okay, so we didn't compact the free space here. We need to compact the space. So whenever we move a block here in our swap, we also need to compact it with the next one. So if... Okay, I see. This is way more difficult than expected. Because if we are... Yeah. If we are here, when we insert... No, here we are right to insert this. But just moving this on the right is not right. So we need to check the one on the left and on the right. So, and this could be a cascade, actually. Because if the one on the left is free, now let's see. If input of right minus 1 is free, then we need to remove the one on right. This is quite difficult to do. I mean, can it happen that we have 2 free spaces? Yeah, it can happen, so we shouldn't do this. We should compact the free space. Like this one, 3, 2, 3, 3, 3, 1 should have become a 3 of 5. So first we can compact the 2 on the left and then the one on the right. Okay. Now we remove the one on the right. Okay. We remove the one on the right. And the one on the right minus 1 becomes a block which is free. And it's the size of right minus 1 plus the size of the block. Okay. Now again, if input, now if the input right is free, we should compact both of them, so we can remove the one on the right and we can again sum this with the one. First we expand one, then we do right. Okay, so again input right is equal to the free block. Let's do it 2 times. Right, then we remove input right. This is not the right way to do it. If right is the less than input len and the right is free. Okay, we can compact the space from the left. Again, this doesn't work. The rate add, oh yeah. The size is this. Input right dot size. So we are compacting while doing that. And it's still not working. So let's see why. File 02, file 92, file 2, file 1, file 4. 3, 4. Why? We didn't move the 7, 3 there. So where is the 7, 3? I think it got removed. Okay. That's fine. So first we need to put the left one. Okay. Otherwise it will compact. Okay. This should work. Again, it doesn't. File of 7, 3 doesn't. So let's print our debugs. Debug of input. It's fine, we can do that. Debug of reference to input. Let's see our nice steps. This is too much. There's so many steps did you take? Oh, I don't want to know. So the first step, we move the 9, 2 to the left. On the second step, we should have moved the, let's see, the 7, right? And we did. On the third pass, we should have moved the 4, okay? Right now we should move the 4. And we didn't. Yeah, we did. There's a 4, then there's a 1, then there's a 5. Then we should have moved the 2. Okay? So we should move the 2 in this next one. So we have a 0 of sys2. We have a 9 of sys2. We have a free space of 1. So we didn't move the 2, which is after the 7, 3. Okay, it's still here. And it's fine. So what did we move? We moved nothing. North of decreasing. Okay, let's do this. So let's do this thing. So back move of input right. Just print this. I want to see what gets moved. So let's check. I don't need to move. I need to see this. So first we move the 9, 2, then the 7, 3, then the 4 by 2, then the 2 by 1, then 2 by 1. After moving the 2, which should be fine, right? So why did the 2? Okay. Less than equal. Let's see. No. Less. Okay. We moved the 2, but where did we move it? Oh, 0, 2, 9, 2, 2, 1, 1, 3, 3, 4. Why is the 7, 3 still there? Did we increase the size? 2 plus 2 plus 1 plus, I think it's even bigger. Let's try again. So where did it move the 7, 3? And why? And where is it? Oh, okay. We should put this one in. We should put this one inside, right? like this. Yes, definitely. So let's do it again. Still not working. How is it? 1, 1, 3, 7, 3, 1, 4, 2, 1. Okay, we have still a free space left here. We have a 3 here. We have 3 of 5. Okay, so we did the wrong thing in here. Let's see. We moved the 9. We moved the 7. We moved the 4. We moved the 2. So where is the 2? I mean, here is right. Is right. We don't have the 3. Why is this a 3 of 5? Let's see them. Let's debug the sizes of these two. Let expected size, which is expected iterator map of block size, sum, and the actual size input, debug expected size, actual size. I just want to see if the sizes at least match or not. Doesn't work? Okay. And it's not working. Okay, we need to give it a type. So this is new size. New size. And let's see how much it failed. Yeah, we are 3 blocks more because we have a free space here, more free space here, another free space here. Okay. That's because we didn't remove the one on the right, maybe. We do it again. Let's try again. I'm just trying. No, it's not this. Why is this 3? So 4 by 2. No, this is wrong. I mean, our expected result is wrong because we have 7 by 3. We have 7 by 3, then 3, 1. This is the expected, okay? On left is the expected, okay? 7, 3. This is not the... This is not the expected we have. I mean, 5 of 7, 3. Okay. 1, 2, 4. Then we have another 1. That's right. Then we have another one. The 3 by 3. No, the 2 by 4. We have 1, then we have a 3, then we have a 4. Then we have a 5, 4, 1, 3, 6, 4, 5, 8, 4, and the 2 block. Okay. Now we can check it better. So what is left here? We have more free space than we need here. And we have more free space at the end. Why? So let's return after the first swap and see. Okay. after the first swap, we removed the 2 nines. We should have left a free space of 2. Why is this a free space of 3? After the 9, we had 9 by 2. We should have swapped the 9 2 with a free space of 2. So, okay, all right, okay. We don't need to do this. I mean, this is okay, but we don't have to do this. We need to do block of free space the same size as the file block. That's why. Right? Oh, we also need to split that. Yeah, we moved just the free space, okay. So now we should have a free space of 2 at the end. Okay. Let's go on with the others. And now it works actually. Okay. Okay. Quite convoluted, but let's do it. We remove this. And at least it works. So let's test just the entire binary. It works. It works. Now we just need to make it work with the with our examples here. So let's start with the expand. Now, part 1 will not work until we have solved everything. So this is like this. Let's start by checking the expand. Or we can just, I mean, we should, yeah. We have a vector of blocks. So the expand here should have, instead of sum 0, we should have sum. Okay, now instead of we need to expand. Actually, it's a different expand function. Okay, we don't change the expand. Let's solve this part. Then we can let's expand blocks. So we just have we don't need this. This is a vector of blocks. Here we just go like this. So out push. Now if is file, we push a block file with ID and chunk size. Else we return a free block. Free block of chunk size. Okay? We return out. Then we have another one, which is the checksum of blocks. So we need to modify the checksum for blocks. Checksum blocks. Now, for each block, so for a block in our input, which is a vector of blocks, for B in input, this is our index. We need to do this. So if let's match B. If it's free file, we do nothing. if it's a file with a given size and a given ID, we need to do sum plus equal and the ID multiplied by the index. So this is like Gauss. So it's ID by from m to m. So we can do this. Is this? I don't think this is right. It's okay. Let's just go and do the thingy. So from idx to idx plus size, we do this. So we get the number, we sum the number. Should work. And then idx plus equal to b size. Okay, we return the sum. The sum is a U64. Okay, it's sum plus equal. This is the index I by id. Now I is 64. That should work. Now we try part 2. Again, expand blocks, defrag blocks, checksum blocks. Okay. And here we should return a U64. One of U64. Why does it not work? Okay, now do this. We do this. We pass mutable reference and we call it disk, which is nicer. And we hope it passes. So here on day 9, we now have 200 to 858. So here in the end, to 858. Cannot even compile. Okay. This is line 244. Okay. I did change it. Let's make it work. And let's try to solve 09. There was some debug still there. It's right. Okay, so we did day 9. This is quite ugly code. And I need to refactor. I think I can refactor it by just changing the checksum and the fragmentation can work the same way with blocks. And the expansion is the only one which is different. So I will try that. Maybe we can try that here. So first thing to do is to transform everything in blocks. And this is not so nice. So the expansion is like that. The defragmentation instead, we can check it. by passing, we need a vector of blocks and the vector of blocks here. So probably input with the frag blocks input. Can we make it mutable? I hope so. And assert eq this. Now let input is equal to input to vec. This should make it work. Okay. Here we need to change this from blocks. So this is a file with ID 0 size 1. No, with ID. Wait. Yes, ID 0 size 1. Then with block. I mean, every sum can become a block. So let's just do this. I don't want to do that. I just want to check it works. So the input is equal to input map. This is an option. So we have the number and match n. Need to collect. This map needs something. So n is a option. So if it's some size, some ID, we need to create a block of ID size 1. Otherwise, with none, we create a block which is free of size 1. This is our map. Let's map. So the expected again is the same thing. So we have the expected and we do this thing. This is a record block. We can check that the fragmentation works. Let's test it. It doesn't work. It doesn't for case 1. We don't need. It doesn't for case 3. But why? It should work. Because it's actually doing this. This is not the right thing to do. You know what? I don't care. I don't care at all. It's all right. Let's keep it like this. We're done. Hope you enjoyed this these 2 hours of me blabbling around this issue and just I mean, see you tomorrow or maybe on Wednesday for day 11. So see you.